Hello, everybody. My name is Varun Senzalraj, and I am one of the instructors for this Python crash course. And I see most of you guys are here today. Some people have told us that they'll be attending a little bit late today, and they'll join in the middle, and that's fine. They'll just watch the recording after we release that at the end of this lesson. So let's go ahead and get started with the lesson for today. So before we get started, I want to talk about a few updates to our organization and future courses. So starting next week, we will be releasing a web design course in which we'll be going over everything you need to know for creating a very appealing and beautiful website. And I'll show you some examples of some websites you'll be able to create at the end of the course. So right here, here's a website that we've created in the past for helping out with COVID-19. And this website was mainly created to help out doctors, because when people were creating these masks, people didn't know where to drop them off or which hospital needed it the most. So we created this website to help out with that. And it kind of gave instructions how to make each of these equipment and donate, where to donate it, as you guys see here. And you'll be able to create these cool websites with nice animations and a really nice look. And here's another example of like a robotics team website that we've created in the past. And in the future, if you were to take this course, you'll be able to create these types of websites. And we'll be even starting from the very basics, starting off with C++, not C++, we'll start off with like the basics of HTML and CSS, and we'll be slowly moving into Bootstrap and finally how JS can be used to make animations on websites. Um, but the seats are kind of limited for that course, and we've got a lot of people wanting to join. So if you ever want a spot in that, go ahead and send us a message, and we can reserve you a spot before we release the sign-up link, which will be coming out soon. Next, we also have CS Logic supplemental videos, which will be released in the near future. And we'll be going over some problems which are even presented at collegiate level class and explaining how to approach a problem and solve it. And it's a really interesting course, and I highly recommend looking into those videos when those are released. And it will just help you overall with your programming mindset and how to solve a problem. Finally, we are starting a Scratch course, and that will be coming out for beginners in the near future. If you have a sibling or a friend who's interested in that, just send you can send them our contact information or our email, and we can get back to them on how to sign up for that course. So moving on, let's talk about our weekly programmer tip. Um, so our programming tip for this week is embrace the failure. Programming is hard, and you will get confused time and time again. Some bugs will take days to fix, and sometimes it'll even take weeks to unravel some concepts when it comes to programming. And you got to kind of be ready for those frustrations. And in reality, this failure is okay because it means you're trying to do new things and challenge yourself every single day and go beyond your limits. So failure is an essential part of learning, and you just kind of got to accept it and use that to your advantage for when it comes to learning a concept or figuring out a problem. But everyone experienced failure as they were programmed. So this is just a very broad tip that will definitely help you out in your programming journey. So let's actually move on to the content for this lesson. So in this lesson, we will cover um, if statements and more in-depth stuff like if-else statements, if-elif and else chains, and more stuff like that. And in the lesson right after our break, we'll be going over dictionaries. So before we even get started, programming often involves examining a set of conditions and deciding which action to take based on those conditions. Python's if statements allow you to examine the current state of a program and respond appropriately to that state. So before we even get started, let's take a quick overview of if statements. So over here, I created a list called number, and I created a list from numbers 1 to 20. And in this program, I want to use a for loop to go through that list and append all the values into a new list called divisible by 2 if the number is divisible by 2. So we'll go number by number, and using a modulo operator, like as you guys see here, which is like the percentage sign. Don't worry about that. We'll be going over that later on in the course. But as a brief overview, all it does is prints out the remainder of a division problem. So we'll start off with 1 and find the remainder of that. And if the remainder is equal to 0, it will append it to the divisible by 2 list. Otherwise, it won't. And it will go through every single number from 1 to 20 and append those to the new list. And as you guys see here, if we run it, these are all the numbers between 1 through 20 that are divisible by 2. If you guys don't understand how if statements work right now, we'll be going step by step on how to write if statements. We'll start off by going over conditional tests and writing conditions. Then we'll going over if statements and combine those together to kind of give you a solid understanding of it. So now, let's go over conditions. At the heart of every if statement is an expression that can be evaluated as true or false, and this is called a conditional test. Python uses these values, true or false, to decide whether the code in an if statement should be executed. If a conditional test evaluates the true, Python executes the code following the if statement. If the test evaluates the false, Python ignores the code for the if statement. That's just like a brief overview of conditionals. So now let's kind of look at the different types of conditionals. So one conditional is checking for equality using the equality operator. Most conditional tests compare the current value of a variable to a specific value of interest. The simplest conditional tests check whether the value of a variable is equal to the value of the interest. And this can be done using the equality operator, which is a double equal to sign. Let me demonstrate that really quickly to give you guys an understanding of how this is done. So right here, we have created a variable and we gave it the value John, right? And now we're going to use the equality operator, as you guys see here, with the double equal to signs. And pretty much how the double equality operator works is it determines if both sides of the equality are equal to each other. So if since the name is a placeholder for John, if John is equal to John, it'll print true. But if we were to change the name, and if we were to run this, it prints out true. But if we were to change the name to anything else, so say we change it to Harry, wait 1 minute, and we were to run this, it prints out false because Harry is not equal to John. So that's pretty much how an equality operator works. You use 2 equal to signs, not 1. 1 equal to sign is defining a variable, 2 equal to signs are equality operator. Now, let's move on to checking for inequalities. So when you want to determine whether 2 values are not equal, you can combine an exclamation point and an equal to sign. And the exclamation point kind of represents not, as it does in many other programming languages. So if you were to read it, the exclamation point is while equaling not, that means not equal to. That's pretty much what exclamation and equal to sign represent. So to demonstrate this, let's kind of improve our code from last time. Here, we're asking the user to input their name. And we're pretty much saying if the name is not equal to John, as you guys see here, the exclamation point and equal to sign. If it's not equal to John, we want to print out the statement, your name is not John. So if we were to run this and say if we put any name, let's put my name, Barun, it will print out the statement, your name is not John, because the statement above is true. Barun is not equal to John. But if we were to type in John, this statement is false. So that means it doesn't run the indented code in the if statement. So because John is not equal to John is false. Okay, so now let's kind of move on to numerical comparisons. I'll answer that question in just a second after we go over numerical comparisons. Moving on. So for numerical comparisons, let's just go directly into the Jupyter notebook to explain it. So as you guys remember earlier, the double equal to sign is the equality operator, make sure both sides are equal to each other. And we can do that for numerical comparison. So in here, we're asking the user to input their own age. And if the age is equal to 18, it will print out true. So if we were to run this and say our age is equal to 18, it'll print out true. But if our age is not equal to 18, it'll print out false. So that's very similar to what we learned already. But with numerical operators, there's many other operators you can use. You can use less than, greater than or equal to, or less than to equal to. So over here, we have defined age as 19. So we want that, and for this statement right here, we want age to be less than or equal to 20, less than 21. And if it's less than 21, it'll print out true. So as you guys see, that's what happened here. If we were to change the age to something like greater than 21, it will print out false because 22 is not less than 21. The same way here with greater than or equal to, if we were to run this, it'll print out true because 22 is greater than or equal to 21. So that's pretty straightforward. But now, if you want to check if two conditions are actually met, or if one of the two conditions are met, how would we do that? So let's go over that really quick. 1 minute. So you may want to check multiple conditions at the same time. For example, sometimes you may need two conditions to be true to take an action. Other times you may be satisfied with just one condition being true. So the keywords and or can help you out in these situations. To check whether two conditions are both true simultaneously, you have to use the keyword and to combine these two conditional tests. And if the test passes, the overall condition will be equal to true. If either test fails or both tests fails, the overall condition will equal to false. The same way for or allows you to check if multiple conditions as well, but it passes. If one of the tests is true, it will the overall expression will pass to be true. But if one were to fail, it will still pass as true because it's either one. Is because the or expression only needs one expression to be true. Let me go ahead and demonstrate this to make it easier to understand. So over here, we're using the and operator, and we have two people. We have two people's ages. We have one person at the age of 22 and one person at the age of 17. So we're trying to determine if both people are over 21, and that's when it comes to the and operator. So if one person was less than 21, that means the whole thing should be false. We want both of them to be older than 21. So that's when the and operator happens. So over here, the age of if we read the statement, 22, which is the age of person 1, is greater than or equal to 21. So that's true. And age 2, which is 17. So 17 is greater than or equal to 21, which is false. And since it's the and operator, both sides have to be true. And since only one side is true, that means it's false overall. But if both sides were to be greater than 21, it will come out as true. So the and operator, both sides, both conditions have to be equal to true for the overall expression to be true. If one were to be false, the overall thing will be false. Same way here, we use or. That means that only one of the sides have to be true. So over here, we have 22 is greater than or equal to 21, or 17 is greater than or equal to 21. One of them is true, one of them is false. But overall, it will come out as true because only one condition has to be true overall. Okay. We'll go over how to use HackerRank to run the code during our break at the end of this lesson. But we'll just go ahead and continue with this for now. Okay, so checking what sometimes it's kind of important to check whether a list contains a certain value before you to even take an action. To find out whether a particular value is already in a list, use the keyword in. Okay, so let me go ahead and demonstrate this to show you how this works. So in this list right here, we have a list of all the requested toppings, but we want to determine if mushrooms is in that list of toppings. So we have to use the in keyword. So all we have to do is type in mushrooms in requested toppings. That way, it'll go through every element in the list and determine if mushrooms is in the requested toppings. And if it's true, then it'll come out as true. But if we were to look for pepperoni in that list, which is not even in that list, and we were to run that, it will come out as false because it's not in that list altogether. So the in operator just checks if that element is inside of the given list. But now let's kind of expand on that. Let's create in here, we created a program for the banned users. And we want to determine if one user is part of those banned users. So we created an if statement. If the user is not in, I forgot to go over the keyword not. So pretty much, if you use not, that means it's not in that situation. So if we were to read this, if the user, which is Sarah, if Sarah is not in the banned users, which is the list of all banned users, print out the statement, the user, Sarah, is not in banned users. So think about it like this. Python's is an interpreting language. It's very easy to understand just by reading it. So we can just read out kind of in simple English. If the user, which is Sarah, is not in banned users, it'll print out the statement, which is true. Sarah is not in that list, so it should print out the statement, the user Sarah is not in the banned users list. And finally, I'm going to briefly go over Boolean expressions. So pretty much, a Boolean expression is just another name for like a conditional test. And it's kind of like, you can either set a Boolean expression to true or false, and it can be changed after it's been evaluated. And usually, Boolean expressions are used to track how the expression of a program and how it changes over like a state of the program. But for example, if you're creating a tic-tac-toe game and you want to determine if a move has occurred, you can set move complete as true once the move occurs. So that's really how Boolean expressions can be used. We'll be going over creating a complete program with a Boolean expression later on, but that's just a brief overview of how Boolean expressions can be used. So does anyone have any questions? Just go ahead and put in the chat and we'll answer that really quickly. Okay, so we're just going to go ahead and keep moving on. Okay, so now that you guys understand conditional statements, you can now start writing your own if statements. If statements are very useful when it comes to programming, and it can be used in a variety of cases. So it's kind of like dig deeper into if statements. So a simple if statement has one conditional statement and one action. So you can put a conditional statement in the first line, and just about any action in the indented block will run if the statement is true. If this is false, Python will ignore the indented block and continue on with the program. So let me go ahead and keep going. Let me show you an example on how this is actually done. So over here we have a simple if statement. We give the age of a person, and we want to determine if the person's old enough to vote, which is they have to be 18 or older. So using a if statement, we determine if the age, which is 17, is greater than or equal to 18, print out you're old enough to vote. Otherwise, nothing will happen. So as you guys see here, 17 is not greater than or equal to 18. So it should not print out anything. And that's what happens. If you were to run this, nothing prints. But if we were to change this to a number greater than 18 or even equal to 18, you'll print out the statement because 18 is greater than or equal to 18. So that's why the indented code will run. Now, let's move on to if-else statements. So here, okay, so often you'll want to take an action when a conditional test passes and a different action in every other case. So Python's if-else statement kind of makes this possible. And if-else block is similar to like a simple if statement, but the else statement allows you to define an action or a set of actions that are executed when the conditional test fails. So let me kind of show you how this works. So we're kind of expanding on the previous program which determines if you're old enough to vote. But this time we want to add, if the person's not old enough to vote, we want to print out a statement saying you're only this years old, you're not legally allowed to vote. So how would we do this? So first we just continue with our if statement, but we also add an else to it. The else will run only if the if statement comes out to be false. So right here, we can input our own age. So say I was only 17 years old. That means I'm not greater than or equal to 18. So it will skip the indented block and move on to the else function. And it does. It skips to the else function and prints out the statement, you are not legally allowed to vote. But if my age was any older, for example, if I was 20, you'll print out the statement, you're old enough to vote, and skip the else statement. So the else statement only runs if the if statement comes out to be false. So now let's go into something a little bit more complicated, the if, elif, and else chain. So often you'll need to test more than 2 possible situations and to evaluate these, you can use the Python's if, elif, else syntax. Python executes only one block in an if, elif, else chain, and it runs a conditional test until one passes. So when a test passes, the code following the test is executed and Python skips the rest of the tests. This is useful for many situations in real life. So let's kind of create a program for a movie theater ticket prices based on the age. So let's kind of go over the requirements really quickly. Here are the requirements. If the age is under 13, it has to be $5. If the age is from 13 to 59, it has to be $10. And if it's above 60, it's $7. So here we're in this program, we're allowed to input our own age, and based on the age, it should give us the correct pricing for our age. So this is where an if, elif, and else chain comes in. So if the if statement tests whether a person is under 13 years old. And if the person is under 13 years old, it should give us a price of 5 and print out the statement 5. The elif line right after is really just another if test or if statement. And it only runs if the previous if statement fails. And at this point of the chain, we can know if the person's at least 13 years old because the first test failed altogether. And if the person's under 60, an appropriate message is printed and Python skips the else block altogether. And if both the if statement and elif statement fails, the else statement will run. So to demonstrate this, say my age was 17. That means theoretically my price should be $10. And that I think it's a little slow right now. That's fine, but it should work because 17 is greater than 13, so it should the if statement should come out as false. So that means since the age is less than 60, that means the price should be $10. Let me try it. Oh, that's fine. Okay. So now let's use a nested if. So let's go over kind of what a nested if statement is. The if, elif, and else chain is it's very powerful, but it's only appropriate to use it when you just need one test to pass. As soon as Python finds one test that passes, It skips the rest of the test. This behavior is beneficial because it's efficient and allows you to test for one specific condition. However, sometimes it is important to check all of the conditions of interest, and in this case, you should use a series of simple if statements with no elif or else statements. This technique makes sense when more than one condition could be true and you want to act on every condition that is true. So let's kind of consider, let's go back to our previous example when it comes to the toppings. And here we're going to use if statements over and over and over again. So here we're trying to determine if mushrooms is inside of the requested toppings. If mushroom is inside of the requested toppings, it should print adding mushrooms. And if pepperoni is inside of the requested topping, it should print out adding pepperoni. And if extra cheese is inside of the requested toppings, it should print out extra cheese. But the reason why we're not using if, elif, and else chain in this situation is because we want to check all of these if statements, even if one is true. In an if, elif, and else chain, if one of the statements are true, it'll skip the rest of the if statements and just move on to the next part of the code. But we want all of this to run even if one condition is met. So as you guys see here, since mushroom is inside, it'll print out adding mushrooms. But then since pepperoni is not in that, and since the statement is true and there's no elif statement after it, it'll continue on to the next if statement. And if pepperoni is in a requested topping, it should print out adding pepperoni. But in this situation, pepperoni is not in the requested toppings and it doesn't print altogether. And finally, there is the final if statement, which determines if extra cheese is inside of the requested toppings. And since extra cheese is inside of the requested toppings, it will print out adding extra cheese. So even though one of the statements is true, it will still continue to run and continue to move on. So that's the end of lesson 5. So the homework for lesson 5, you have a little bit more homework, but this is just to prepare yourself for the programming mindset, which we talked about earlier. We want to make sure you guys are actually applying what you learned. So the first homework is actually go through the Jupyter Notebook for lesson 5 one last time, just to understand the code behind it. Now you guys understand the conceptual part of the coding, but now you have to learn how to actually write the code yourself. So just going over it one more time, understanding how it works will definitely help. And at the same time, we have practice assignments inside of the Jupyter Notebook, which you can actually practice inside of the Jupyter Notebook like previous Jupyter Notebooks in the past. And this way you'll actually solidify the concepts that you learned. Next, the HackerRank assignment. If you guys don't remember, HackerRank is a website in which you can accomplish, you can practice tasks for a specific programming language and actually get yourself ranked internationally. At the same time, if you were to complete a certain amount of tasks, you'll be given a star. And the stars range from 1 to 5. And if you're a 5-star rating, that means you have mastered that language. And companies, colleges, and many other people on the platform will be able to see that you actually understand the language, and which can potentially lead to other programming opportunities. And completing all the HackerRank assignments is definitely beneficial. So for this week, we want you to complete the Python if-else HackerRank assignment. And we've already gone over this, so it should be pretty straightforward. At the same time, you guys already learned about for loops in the past. We just want you to complete the for loop assignment here. So we can go ahead and take a break now. I'll go ahead and answer the question for the HackerRank HackerRank, how to use HackerRank to run the code. And other than that, you guys can add your questions in the group chat. We'll answer them during this break. Otherwise, you guys can just relax for a few minutes. So let me show you how to use HackerRank and actually type your code. So right here, I'm on like a alternate account, so you guys can actually view the tasks. And here, if I want to do any assignment, I just all I have to do is go on the website and create an account. And then after that, there's going to be a section right here that says skills available for practice. You can click any, there's all these languages, and you can choose whichever language you want. And for right now, we're focusing on Python. So you guys can click Python and learn. Then you can filter out the specific tasks right here on the side with the difficulty over here. At the same time, all the subdomains over here. And that's really up to you. But for example, if you want to do the Python if-else assignment, it will kind of go over how to write like the basics you need to know before writing the code. So, and you understand how to solve the problem. Then over here is where you write your code. You don't write it here. You skip all this part, but you write your code under here. And I'm not going to write the code out here right now because this is one of the homework assignments, but yeah, you would usually just use this and start writing your code. And once you were to write your code and submit it, so if we were just print out, it'll confirm. So it will determine, there's going to be many different test cases in which it'll produce random numbers. And it will check your answer compared to the answer that has inside of its own database. And if your answer is wrong, it'll tell you your answer is wrong. You'll have to do the assignment again. Otherwise, if you get it right, you could submit your code and you'll actually get an achievement for that. So that's really how HackerRank can be used. But yeah, so if you have any other questions or if you want clarification on how HackerRank is used, just put it in the chat and we'll answer it. Other than that, we'll just take a quick break. Okay, we're gonna go ahead and start up with the next lesson for today. And for the second part of the lesson, we're gonna be talking about dictionaries. Python's dictionaries allow you to connect pieces of related information. Understanding dictionaries allow you to model a variety of real-world objects more accurately. You'll be able to create dictionaries representing a person, then a store, or even a person's occupation, a car, anything. You can store their name, you can store a person's age, location, profession, and any other aspects of a person you can describe inside of a dictionary. You'll be able to store any two kinds of information that can be matched up, such as lists of words and their meanings, a list of people's names and their favorite numbers, a list of mountains and their elevations, and much more. So let me actually show you a simple example of a dictionary. You don't really need to understand it right now. I'm just trying to expose you to how a dictionary looks like. So right here, we have a dictionary about a car. And in the dictionary, we have the car brand, and we have the car model and the year. And each key value pair, which will be explained later on, correlates with each other. Brand correlates with Ford, model correlates with Mustang, and year correlates with 1964. And if we were to print it out, it looks exactly how we stored it, because that's how a dictionary looks like. But if we were to print out specific elements in the list, if we were to print out what the brand was, we get Ford. If we were to print out the model, we get Mustang. So really, dictionaries kind of take a lot of practice to understanding how to use it, but we'll be going over a lot of examples in this lesson. And at the same time, we'll give you practice assignments to actually understand how to use dictionaries. And they're a very useful tool when it comes to programming and making applications. So let's go ahead and move on. A dictionary in Python is a collection of key value pairs. Each key is connected to a value, and you can use a key to access the value associated with that key. A key's value can be a number, a string, a list, or even another dictionary. In fact, you can even use an object that you create in Python as a value in a dictionary. In Python, a dictionary is wrapped in braces, with a series of key value pairs inside of those braces, as shown in the earlier example, or as shown here, with each thing is paired with a key and then a value, and that's called a key value pair. So let me kind of show you that in the same example we talked about earlier. So here we just redefine the dictionary, and in which we're just describing a car. And this car has a key value pair for a brand, which is a brand and Ford, a model is Mustang, and year is 1964, right? So that's how you would create a dictionary. You define your dictionary name, then you define your key value pairs for each pair. One for the key, one for the value. A key value pair is just a set of values kind of that are associated with each other. When you provide a key, Python returns a value associated with that key. And every key is connected to its value by a colon. And individual key value pairs are separated by commas. You can store as many key value pairs as you want inside of a dictionary. It really doesn't matter. So let's try and demonstrate a key value pair again. To demonstrate it again, we have a key value pair. We're just redefining key value pair brand. So this is one key value pair. Brand, it correlates with Ford. So if you were to ever call the brand for a dictionary, it will correlate to the value, which is Ford. So we'll actually talk about how to access the values inside of a dictionary now. Okay. So to get the value associated with the key, give the name of a dictionary and then place a key inside of square brackets, as you guys can see right here. So let's actually show you guys how to access values inside of a dictionary. So over here in this example, we're just getting the same example that we had above. And we want to get the specific model of that car that we were describing in the dictionary. To get that, all we have to do is first you have to use a print statement if you want to display it in the terminal. And we define the dictionary name, which is car1, and in square brackets we put our key, which is model. And since the key correlates with the value, if you were to ask for the key, it will give you the value, which is Mustang. So that's how you access specific values. If you ever want to access another value, for example, say we want to know the year of the car, all you have to do is replace the key, which is year. If we were to print that out, it'll give you 1964. So really the way to think about it is it's kind of like a map where you have a key for a map, like a triangle is mountain. That's the same way. So if you were to put like in a dictionary, if you're describing a like a map key, you would say the key would be triangle, and then the value would be mountain. That's really how you access values inside of a dictionary. So now let's actually go over adding new key value pairs. So here, before we get started, dictionaries are dynamic structures, and you can add values to a dictionary just like a list. For example, if you want to add a new key value pair, you would give the name of the dictionary, followed by the new key in square brackets, along with the new value. So let's actually look at an example of how this is done. Here, we're taking our same example about the car and the car that we're describing. And we want to add the color of the car to the dictionary. How do we do that? First, we define the name of it. We write our name of the dictionary, and in square brackets, we put our new key, which is color. And we want to create a value that correlates with the color, which is red. And so then we equal the color as red. And if we were to print this out, as you guys can see here, color is inside of that dictionary. So that's how you add new key value pairs. But you can, because of this, you can recreate dictionaries from scratch. So let's recreate the same dictionary above by adding new key value pairs over and over again. This is like very similar to the append function in a list. And if we were to do that over and over again, in the end, the lists are identical to each other. So what if you wanted to modify a value? If you wanted to modify values inside of a dictionary, it's the same way of adding a new value, but except you're just redefining a specific key. So here, say we want to change the year of the Mustang. Say we got a newer model of the Mustang, but everything else is the same. So all we have to do is we define the name of our dictionary, which is car1, and in square brackets we put the key in which we want to change, which is year. So and then we have to correlate a value to that year, to the existing years. We want to change that value. So we change it to 2000, and if we were to print that out, as you guys can see here, 2000 is now added to the dictionary instead of 1964. So that's the way you can change values inside of a dictionary. It's very similar to adding a value, except you're just redefining an old value. So now let's go over how to remove key value pairs. When you no longer need a piece of information that's stored inside of a dictionary, you can use the delete statement, very similar to a list, to completely remove a key value pair. All delete needs is the name of the dictionary and the key that you want to remove. So let's look at an example of how this is done. But remember, when you use a delete statement, it permanently deletes the key value pair from the dictionary. So if we were to look at this, we have a list, or we have a dictionary of that we had above, but we want to delete the year of the car, because maybe the year is not relevant for this car anymore. So if we were to delete this altogether and we were to print this out using a delete statement, we can see that it's completely deleted from our dictionary. All we had to do is type in delete, and we just type in our name of our dictionary, and in square brackets we put the key, the value of the key value pair in which we want to remove. And if we were to do that, it completely removes it. And a really cool thing you guys can do with dictionaries is you can format it in a more readable way. So over here, we have the same dictionary as we have here, but it's all in one line. But if we want to make it more readable, all we have to do is for every key value pair, we just add it to a new line. This way, it just makes it more readable for a person to actually look at the code, and it makes adding new values much more easier. So that's just like a simple tip that'll help you out when it comes to creating dictionaries. So now let's use the so now let's kind of go over the get function. Using so if you're using keys and square brackets to retrieve values that you're interested in from a dictionary, it may sometimes may cause a problem if it's not inside of that dictionary, and you'll get a nasty error message. So how do we get rid of that? Before we even tell you how to do that with the get function, let's analyze what happens if we're trying to retrieve a value which is not even in that dictionary. If we were to run this, so right here we're asking for the wheel size of a car, and we're trying to retrieve that value which you guys looked at earlier, but it's not in that dictionary. So instead we get a key error, which is pretty much saying it's not inside, that key is not inside of that dictionary. But there's a way around this. So say you had a dictionary that was constantly updating and you didn't know if the wheel size has been updated yet. You can use the get function. All it really does is, so pretty much the get function is similar to, the get function is pretty similar to what we did earlier of retrieving values, but except when we pass an argument after the key which we want to retrieve that will display if the key value pair is not even inside of the dictionary. So here we just type in car_1.get, and inside the parentheses we type in the key value pair in which we want to retrieve, and after the comma we type in the statement which wants to be displayed if the key value pair is not present. So here, if we were to run this, it will print out no wheel size given, because wheel size is not even inside of that dictionary. But if we were to add wheel size to that, one second, and say we put 34, it will print out the actual value instead. So it's just like this way it just makes it look cleaner, and it's an easy way to avoid error messages, and it will definitely help you out when you are creating applications. Now, So does anyone have any questions about what we've gone over so far before we move on to actually looping through a dictionary? Okay, then we'll go ahead and move on to the next part. So before we explore the different approaches to looping, let's consider a new dictionary that's designed to store information about a specific user on a website. So here we have user one. We keep the username, the password, the first name, and last name inside of a dictionary. You can access any single piece of information about that user by retrieving it, as you guys have learned earlier in the program or in the lesson. But if you want to see everything that's stored inside of the user's dictionary listed in a nice readable format, how would we do this? You can use a for loop to go through that entire dictionary and print it out in a readable way. So as you guys see here, we have the same dictionary with the user information, and we're using a for loop to actually go through every element in the list for every key and value and print out the key and value for each key value pair inside of the loop. So what we're doing is we create two variables that will hold a key and value in each key value pair, and we just, you can choose any name for that. We just use key and value in the situation, but it doesn't really matter. And you can also use abbreviations like K and B instead. It really doesn't matter because remember, this is acts as a variable and just associates the value to each other in a for loop. So if we were to even change this to K and B, it would work the same. And that's pretty much how this works. So let's actually go through all, like, how to loop through every single key inside of a dictionary. So the keys method is useful when you don't need to work with all the values inside of a dictionary. You only want to work with the keys inside of the dictionary. So let's actually loop through the user dictionary and print out all the keys of the dictionary. So let's look at this dictionary right here, and using the keys method, we are looping through every key inside of that dictionary, and we're printing out all the keys. So as you guys see here, 4 keys in the user.keys, which is the key method, we print out all the keys in title case. So we print out username, password, first name, and last name. So that's how we can use the keys method to actually loop through all of the keys inside of a dictionary. But if you want to loop through a dictionary and keep it ordered at the same time, the way to do this is using the sorted method. You guys, for lists, there was a sort method that would actually alphabetize everything. But for dictionaries, you have to use sorted, which is how it works. And for example, we have a dictionary which stores which correlates a student with a sport. For example, Kanye plays basketball, Kevin plays track and field, Colin plays cross country, Ruben plays tennis, and Arnold plays golf. And we're looping through that dictionary, and we are just printing out all of the keys in a ordered format using the sorted method. So all we have to do is just use the sorted and wrap the student sports.keys, which is the keys method, with sorted to actually order it in an alphabetized order. And if we were to print this, it'll print out alphabetized A, C, K, K, R, and print out the print statement that correlates with it. And that's how the sorted method works. And finally, if you wanted to loop through all the values inside of a dictionary, you can use the values method, similar to the keys method. And for example, say we want to display all the sports the students played without the person's names inside of it. Instead of keys, we just type in values instead. If we were to print this out, we can see in a sorted format, because we're using sorted, all of the sports or alphabetized. Okay, so that was kind of a complicated concept and it's kind of hard to explain, but if you guys have any questions, go ahead and put in the chat. Otherwise, we'll move on. But when it comes to using dictionaries, it's really just about practicing it over and over again. And you really don't have to memorize all of these methods that we're displaying in this course. It's just really about understanding how you can use this. So if you're ever to forget something, you can always look back at the API or documentation for Python and always gather that information whenever needed. So you're not supposed to memorize the code. You're supposed to learn how to apply the code. So that way, if you were to forget it, you can just quickly look at an example and learn how to apply it to your code at any time. But yeah, let's go ahead and move on to our next part. So sometimes you want to store multiple dictionaries inside of a list, or a list of items as a value inside of a dictionary. This is called nesting. You can nest dictionaries inside of a list. A list of items inside of a dictionary, or even a dictionary inside of another dictionary. So let's kind of go over the three types: a list of dictionaries, a list in a dictionary, and a dictionary inside of a dictionary. So let's go step by step and analyze it. So here we want to, so let's say we have 3 different cars and each of them have the same keys but different values. For example, we have one Ford Mustang, one Tesla Model X, and one Toyota Camry. And we kind of want to create a fleet of cars or a group of cars inside of a list. How do we do that? You would create the dictionary separately, as you guys see here, for each separate car. But then you would just embed it inside of a list. So for example, we create a list of cars, we just put each dictionary inside of each element inside of a list. And if we were to print this out, we can see, we use a for loop to print it out. We go for every dictionary. If we were to print out each dictionary one by one, you can see here, there's Ford, Tesla, and Toyota at the end. So that's how a list of dictionaries actually works. But now let's see how you can use a list in a dictionary. So rather than putting a dictionary inside of a list, it's sometimes useful to put a list inside of a dictionary. For example, let's consider that you may be describing a pizza that someone's ordering. And if you were to use only a list, all you can really store is a list of pizza toppings. But with a dictionary, a list of toppings can be one aspect of the pizza that you're describing. So as you guys see here, we have a dictionary of the pizza. We say, for example, one key value is crust. We want the crust to be thick. But for the toppings, we use a list embedded inside of the dictionaries to put all of the different type of toppings. And this can be useful in this case, because if you were trying to print out the toppings, instead of having to create multiple dictionaries for one just for toppings, one for just this, you can just put it inside of one dictionary and make it look more clean. So if we were to run this, you guys can see here, mushrooms, and we were printing out a statement saying you ordered a pizza with the following toppings. So and it goes through that list in toppings, it prints out every single topping. And that's really how you use a list inside of a dictionary. Don't worry about actually learning how to code this. This can easily be accomplished just by looking through the Jupyter notebook and doing the practice assignments. But for now, just understand how a list in a dictionary can be used. And finally, we can do a dictionary inside of a dictionary. You can nest a dictionary inside of another dictionary, but your code can kind of complicate it when you do so. For example, if you have several users for a website, each with a unique username, you can use the usernames as keys inside of a dictionary. You can store the information about each user by using a dictionary as the value associates with their username. In the following example, we store 3 pieces of information about each user. The first name, the last name, and the location. And we'll access this information by looping through the usernames and the dictionaries of the information associated with the username. So first, we define a dictionary called users with 2 keys, one for the username, Einstein and Mercury, and the value associated with each key is the dictionary. That includes each user's first name, last name, and location. We loop through the user's dictionary, and Python associates each key to the variable username. And the dictionary associated with each username is assigned to a variable user_info. Once inside the main dictionary loop, we print out each username, and we start accessing the inner dictionary as well. And the variable user_info contains the dictionary of the user information. And it has 3 keys, first name, last name, and location. And we use each key to generate a neatly formatted full name location for each person, then print a summary about what we know about each user. This is a little bit complicated concept. It's not really a beginner concept, but just understanding that you can use a dictionary inside of a dictionary can be very useful in any application. Because if you were to need to use that, you can always just look at examples and see how you can combine them together for your actual program. Just understanding how to use it is very important. So that's pretty much all we have for lesson 6. For the lesson 6 homework, all we really have you guys doing is going through the Jupyter notebook so you guys can understand how to actually apply dictionaries. We have practice assignments for each section of lesson 6, but that's pretty much all the homework for this lesson. If you guys have any other questions, go ahead and put in the chat. Otherwise, we can go ahead and end it here.